Okay, so we have our second example here. Let's do some extra practice verifying if these two functions are inverse to each other. So, what we're going to do is do composition for both. One where h going to p, and then p going to h. So the first one we're going to do is p of x inside of h of x. So we're going to plug this function into that x. I'm going to write -4 because of that, minus 7. Now I'm going to write in this whole function in replace of that x. So -2x minus 4 over 7, and then that's it. So again, this whole function p of x is inside of that x from h. So parenthesis, the whole thing is divided by 7. Nope, my mistake. 2. That 2 right there. So this -4, this minus 7, that 2, this whole function is replacing that x. Alright, so as before, we have a whole number multiplying to this fraction, and it's the same as the denominator. So, oh, look at here, we have a negative. So I'm going to take this step by step. So -4. Now, let's focus on the number only. 7, and since this is a denominator, so basically it's 7 divided by 7. So that would be 1. Now, we have -7. So, okay, so -7 divided by 7 is just -1. So I'm going to write 1, and I put the top. So -2x minus 4. The whole thing divided by that 2. Now the reason I took that a step slower is so that you can see that we still have that negative. So -7 divided by 7 is that -1. And here's what's going to happen. We're going to distribute that -1 to everything inside. This is where we have to be absolutely careful when we have negatives and distributing. Because if you don't, you might get a different answer. Alright, so I'm going to bring it up to the top. Alright, so we have -4. Now we're distributing that -1. So -1 times -2x, that's just plus 2x. And then -1 times that minus 4, that's just plus 4. The whole thing divided by 2. So we have -4 plus 2x plus 4. And then let's combine some like terms on the top. The only thing that's like terms on the top is -4 and plus 4. So -4 plus 4 will be 0. They're going to cancel out. Then we're left with 2x divided by 2. And then again, 2x divided by 2, so 2 divided by 2 is just 1. It won't equal to 0, it won't cancel out, it's just divide itself out to 1. So basically, 2x divided by 2 is just x. So, again, be careful with your signs, you might get different signs here, and we probably may not just get x, we probably got a different answer. But now we're just proving that HP of x will equal to 0. Alright, now we're going to do the other composition. Alright, now let me write that h of p of x equal to x. So we just proved that this equal to x. Now we're going to do the reverse order. So now we're going to plug in h of x into p of x. Okay, so again, this h of x, this function, we're going to that x. So for p of x, it's negative 2. Alright, now, since it's an x, that means we plug in this function. So, negative 4 minus negative 7x divided by 2. Alright, let me put in the parenthesis. And then minus 4, the whole thing divided by 7. Alright. Now, just like before, we have a negative 2. And it's being divided by that 2. So again, when you have a whole number outside a fraction and it's the same as the denominator, you can just divide them. So negative 2 divided by 2, that, I'm going to write it right here, equal to negative 1. And then, we're left with just the numerator, which is negative 4 minus 7x. And I'm going to close this. Then we bring out that minus 4. The whole thing divided by 7. So again, negative 2 divided by 2 is that negative 1. Now, I'm going to distribute that negative 1 just like in the last composition. Alright. So negative 1 times negative 4 is just 4. And then negative 1 times minus 7x is just plus 7x. Minus 4, that was from here. The whole thing divided by 7. Now, we're going to combine the terms, the like terms on the top. We have a 4 and we have a minus 4. They're both numbers. 4 minus 4, well, that's just 0. They cancel out. Now we just have left 7x divided by 7. And again, it's just dividing. They're not going to cancel out since they're the same. Divide, not cancel out. 7x divided by 7 is just a positive 7. I mean, positive x. I'm going too fast. Alright, so that's good. Now, there's one thing I forgot to mention, is that it has to equal to a positive x. So, the composition, if we're verifying that they are inverse to each other, they both have to equal to positive x only. So, the composition where it's h of p of x equal to x, and the second composition, p of h of x equal to x, they both have to equal to a positive x. If, in the event, one of them equals to a negative x, then they are not inverse to each other. So, let me write out examples of not inverse to each other. So, one would be like we just mentioned, negative x. Another one would be x plus 1. Another one would be 2x. So, all of this are not inverse. Not inverse to each other. So, if you have like x plus 1, then they are both not inverse to each other. If one of them or both of them have negative x, not inverse to each other. If something like 2x, still not inverse to each other. So again, they both have to equal to a positive x. Alright? Not negative x, not x plus 1 or x plus 2 or x minus 1. Not 2x or negative 4x. It has to be a single positive x in order to be inverse to each other.